First of all, I would like to Climate Social Forum for organizing this time-demanding program, and also uh, the idea on which they are working called Agora. I really like this idea, uh, basically for collaborating with experts, with practitioners, with youth for take actions for climate change mitigation and adaptation. So my name is MD Humayain Kabir. My educational background is environmental science. I studied in back home in my bachelor and master's degree at University of Chittagong in Bangladesh. And then I moved to Asian Institute for Technology for doing a postgraduate certificate on coastal zone management. And then I studied in climate change at the University of East Anglia in UK. And currently I am doing my PhD also in climate change at the Wegener Center for Climate and Global Change. Apart from my educational activities or formal education, I also attended more than hundreds of international trainings related to climate change, climate extreme, or climate change induced natural disasters from, for example, I would say top 5 universities in the world. Besides, I also climate reality leader trained by Al Gore, the former president of USA, and I'm working in climate extreme or climate change issues over the last 12 years in different countries, including Bangladesh, India, Thailand, UK, and then now in Austria. And my research focus on, as I said earlier, in basically in climate extremes and also climate change induced natural disasters. Besides, I'm also focusing on different climate change adaptation strategies, particularly in the developing countries. Professionally, I am teaching in a public university called University of Chittagong in Bangladesh as an associate professor. And currently I'm working as a scientist at the Wegener Center for Climate and Global Change. So thank you so much, first of all, for inviting me for this social forum and for this virtual conference. And today I will talk about climate extremes and how to predict these climate extremes and how this prediction can foster adaptation practices. So if I look at the global grand challenges nowadays, what we are facing now, so World Climate Research Forum, World Climate Research Programs has identified the climate grand challenges. And they reported that heat waves, heavy precipitation, drought, storms, those are the main grand challenges as a weather and climate extremes. And to work on it, actually, we need to understand, we need to simulate, we need to attribute, and finally, we need a strong documentation of this weather and climate extreme events. And actually, we need to answer some question to understand more deeply on these issues. For example, are the existing observations sufficient to understand the climate extremes, and how actually model predicts this climate extreme events, and how we can attribute this climate and weather extreme. For example, is there any influence of human activities on the intensity and frequency of these extreme events? So before going to more detail, I would like to give an overview on extreme events. Recently, a paper published in Science by Pendergrass from US. So she is asking what precipitation is extreme. For example, we know that precipitation extreme is also one of the major extremes now we are facing in current world. And she tried to define how much precipitation is extreme. And she argued that the definition of this extreme precipitation varies from location to location, and also it depends on so many other factors. For example, we know that increased temperature has a very strong influence on the intensification of the precipitation, what we call scaling factor, meaning that if 1 degree temperature is increased, it has a scaling factor to intensify at least 7% more precipitation compared to as usual weather or climatic conditions. And with the increasing temperature, this precipitation extreme is also increased, but not at very high temperature. Its limits up to 22 to 25 degrees centigrade temperature. And if we actually want to know how an extreme event is look like, you can see in the right panel here. I have shown that, for example, for temperature, if we see the distribution of this figure, you can see at the right hand side where it's marked as hot, meaning that in high percentile, or in the left tail, if the temperature distribution of a certain location lies either within the left tail or in the right tail, then we can say this weatheric condition is extremely hot or extremely colder. So meaning that in statistically, we are saying that if the certain value of climatic parameter, for example, precipitation or temperature lies at the top, for example, 95 to 99.9 or 90% percentile, this particular events we call it's a extreme event. So if we want to look closely, what's the main reason for these extreme events around the world, then actually we people are the main reason for this. The statistics shows that around 152 billion tons of man-made global warming pollutions are emitted into the atmosphere in every 24 hours. So it means that our atmosphere is the open dumping grounds for all types of atmospheric pollution. That's why the Earth system, we know that the sun is the main source of all types of energy. And when this energy comes from the sun to the Earth's surface, some of this energy is either reflected, stored, or scattered. And when it's going back to the atmosphere, this infrared radiation is trapped by the atmospheric pollutions, what we call greenhouse gases. For example, if the concentration of carbon dioxide is increased into the atmosphere, it acts like a blanket, meaning that the heat cannot go beyond this layer, or heat cannot penetrate this layer, and this layer is becoming thicker. As you see in the figure, that it's actually block the whole Earth system, and Earth become more warmer, what we call global warming. So if this global warming or energy imbalance or heat imbalance occurred in the atmosphere, then actually it directly drives to occur different types of climatic extreme. For example, heat waves or thunderstorms or even extreme precipitation. So if we want to understand what are the main causes of this greenhouse gas emissions into the atmosphere, then we can see very easily in this comprehensive figure you can see there are so many different sources of greenhouse gases. And all of those mostly are linked to our human activities. We call this anthropogenic activities. In this figure, you can see clearly that different industrial processes, from agricultural activities or real industrial processes, or crop burning, or over fertilization in the agricultural lands, or all types of transportation, for example, land transportation, sea transportation, even air transportation, and different types of forest burning, coal burnings, and also coal plants, landfills. So all those are actually energy intensive activities. And traditionally we use the fossil fuel or oil based activities. As a result, a huge number of greenhouse gases are emitted into the atmosphere, which actually main drivers for global greenhouse gas effects. And as a result, our climate is changing, and we call this as a climate change. And as the reasons is mainly from human activities, that's why we call this as a anthropogenic climate change. So if you look at this figure to understand how this greenhouse gas emission into the atmosphere affects the global surface temperature, and which differed from the average temperature from 1980 to 2019. And if you see the anomalies from the zero bar, zero line, horizontal line, you can see that from 1980s and onward till 2019, there is a dramatic increase in global surface temperature. And analysis shows that the temperature is increased around 1 degree centigrade compared to the pre-industrial periods. So it means that in pre-industrial periods, we had less industrial activities, as a result, less greenhouse gas emissions. And in recent times, particularly from late 1980s, we have so much greenhouse gas emissions in the atmosphere. As a result, the global surface temperatures increased, and it also clearly shows that the most of the hottest years in the history from 1880 in the recent years, and also most of the hottest years in just in last 2 decades. So it's meaning that we have a very strong climate signals, and our temperature is rising so quickly. So this figure actually clearly argued that climate change is real, and it's a human-centric activities, meaning this is caused by human activities. And due to this temperature changes and changes in the whole our climate systems around the world, there are so many climate and weather catastrophes or climate or weather extremes. So again, if we see from 1980 to 2019, we have seen that the number of events, for example, extreme temperature, drought, fires, or flood, or slides or landslides, and storms or cyclones, all of these are increasing rapidly over the time, meaning that the weather and climate related extremes has intensified over the time around the world. So these climate change induced different weather and climate extremes actually affects the 5 dimensions of our sustainable development. Here, in this figure, you can easily understand that the 5 P's, what we call planet, people, prosperity, partnership, and peace, all these 5 dimensions of sustainable development is directly affected by weather and climate extremes. For example, the whole planet or the natural environment has altered drastically due to these extreme events, and people from different parts of the world are suffering uh, from different negative impacts. For example, less access to energy, inequalities, different types of health hazards, and it actually affects the prosperity of our society. It increases the social inequality and social instability, and and in turns it directly affect the peace of the society. It drives to people to move from one place to another, what we call climate induced migration, particularly in the low lying countries. For example, the country from where I born, in Bangladesh, we have a very long coastlines and low lying areas near to Bay of Bengals. That's why, due to sea level rise and other natural disasters like cyclones and coastal floodings, people are moving from one part of the country to another, and even some people are moving across the country in different other countries. And that's why it needs a very holistic approach to combat this climate change in these different events, and we should work together, combining all this public and private sector, and we need to work on the basis of climate justice, and also we need to work together on the principles of common but differentiated responsibilities, meaning that the everyone should to come forward to combat this climate action, to climate change, and this activity should be on the basis of their historical um, historical responsibilities. It's, in other words, it can be said like that: based on your historical emission into the atmosphere, you should contribute, or you should compensate, or you should work to help the most vulnerable climate countries in the world. And if we see as a case study in Graz in Austria, where I'm working now, so here we have seen that there is a strong temperature extreme in Graz. We analyzed the data from 1970 to 2019, and this figure is clearly shows that the temperature is increasing. And in recent times, the anomalies is crossed over 2 degrees C. So it means that if temperature is raised so rapidly, it will intensify the extreme precipitations. And scientifically, we call this CC rate, and CC rate meaning the scaling rate with precipitation and temperature for 2 degrees centigrade should be around 14% increased intense precipitation. As a result, we have seen that here in most of the Austrian cities or municipalities, they are experiencing actually flash floods due to very intense precipitation in a short times, what we called convective extreme precipitation. And this intensification of this short duration extreme precipitation has a very strong influence by the increased temperature in this region, particularly in the summertime. And if you want to predict these extreme events for any extreme events, so I'm showing here a very schematic flowchart of how we can actually predict this extreme event. So for this, actually, we need to set up our research question and research area, collecting all the related climate change and the weather data. Then we can set up an extreme weather model and climate change model, and we can determine which actually factors or indicators are responsible for this extreme event, and then we can construct our extreme climate model, weather model. And here we can use different machine learning tool. I will talk about this machine learning and AI later, but here you have seen this SVM, this is support vector machine. So it's one kind of machine learning tool which can be actually used for predicting the the predictors or the indicators which actually are driving factors for these extreme events. And on the right panel, you have seen that we can set up another climate change model. And again, we have to determine the indicators for this, and we can use linear regression models, for example, and then we can actually construct another climate models where we can use different neural networks or artificial neural networks, and we can predict from the climate model and also the neural network model. And from these two predicting models, we actually finally we can analyze final prediction analysis, and we can see actually which model setup is showing the more accurate result or more trustworthy results. So we can actually use so many other machine learning tools also. For example, nowadays we can use machine learning and artificial intelligence for classification of our extreme events. For example, which extreme events are, for example, more stratiform, or which are more convective, or we can classify it in different ways. It's actually on the basis of your research questions or what you actually want to find out from your work. And we can use these different machine learning tools. For example, we can use artificial neural networks, or even CNN, or other classification tools, which we call CART. So here we can use, for example, different linear regressions, or support vector machines, or other machine learning tools for example, random forests. So and also you can apply grid search to find out actually which model is working better. You can use actually bootstrapping methods. So actually we can use so many machine learning and artificial intelligence methods or tools to understand the extreme weather events and predict them. For example, recently one study in Nature they used the deep learning methods to understand the process of Earth system science, and also they tried to actually differentiate the extreme weather automatically using deep convolution neural networks. So it's one kind of artificial intelligence and deep learning techniques through which actually we can get more accurate prediction about extreme events. So now question is, as we know, for particularly understanding the very short duration extreme precipitation events, we know that all extreme events is not long run. Some events are occurring very fastly and for short time. So for this, to understand this, we need actually very high resolution and very dense observations or stations weather data to actually assess these extremes. So here is an example actually to answer this question. Actually, our existing observations are sufficient to assess these extremes. Here, daily maximum precipitation in the left panel has shown how these trends are changing over the time, and in the right panel, it's showing that as most of the world don't have very intense station observation data, so there are so many missing data. So that's why in the right panels, it shows in the anomalies there are so many uncertainties, and if you show the graph, it's clearly shown that the uncertainty range is relatively higher. So it actually, on the other hand, it's unable actually, or it's don't capture the whole scenario of predictions more robustly, meaning that as there are so many missing data, that's why the model uncertainties is relatively higher. So if we want to improve our model performance to predict particularly intense precipitation or extreme precipitation, we need actually so many observations. So alternatively, remote sensing data is now widely used to actually overcome these limitations. And around the world, you know that in European scale, from European Space Agency, they have Sentinel-2 or 3, and also in NASA, they have Global Precipitation Mission, so that we can get a continuous precipitation data which is remotely sensed from the atmosphere, so that the model can predict the extreme events more accurately. And if we see this model performance, and very recently, a study done in ETS Zurich in Switzerland, and they're showing also that the observations and the most recent model generations outputs has a consistency in recent times, meaning that they are using very high resolution climate model or regional climate model to see how this extreme heavy precipitation, for example, in 99% or 99.9% percentile, and how observed precipitation and model output data, for example, from CMIP 5 or Codex, and how this two setup actually behaves, and how we can compare the findings of observations, and also from models output data. So here in the left panel, you can see that the observation from 1951 to 1980, and others model output data, there is a consistency in model output or model prediction. So how actually this climate event prediction help to take urgent and robust adaptation techniques. So if we want to understand this, we need to understand another figure which is taken from IPCC last report. And here you can see that the climate risks or risks due to weather and climate extremes is a function of hazards, vulnerability, and exposure. And these three are actually driven by two different systems. For example, the climate system, which is shown in the red side, and a socioeconomic process, which is the right side. So if anyone take adaptation and mitigation actions immediately by understanding the climate and natural variability or anthropogenic climate change, then it's possible to reduce the risks, and also taking more realistic and more robust and quick climate change actions or climate adaptation actions. So in this sense, actually we need very good extreme events predictions. It depends on how accurate your prediction is. So if your prediction is more accurate, then the communities or climate vulnerable people can take more accurate climate adaptation actions or practices. So to actually to improve the credibility or reliability of this climate extreme prediction, in Austria, for example, where I am working now, Austrian meteorological departments, they developed a new system, what they called what they called INCA. So INCA meaning the analysis of um, integrated nowcasting analysis system, meaning that it uses all the information sources from observation, from satellites, from radars, and by combining all these things using numerical weather predictions, they are continuously forecasting and predicting the next day or for example, next 1 hour weather and climate conditions. So in that case, the realistic and more accurate forecasting or prediction of our weather system is really important to take proper um, uh, climate adaptation practices. Similarly, in my back home in Bangladesh, they have also launched numeric weather prediction products, and also they have another recently launched another program called Integrated Forecast Dissemination Portal, which we call Instant. So both two are actually using for predicting our weatheric parameters, for example, temperature, precipitation, or humidity, or other climatic and weatheric parameters, so that the uh, the farmers or the poor people or who are living at the near to the coast, they can know beforehand what is happening next, or what is happening just after 1 hour or the next day, so that they can adapt more quickly. And Bangladesh has also remarkable progress in climate actions, particularly for climate change adaptation. And we all know that Bangladesh is globally known as the capital for climate change adaptation, because the people who are living in the coastline areas, they are growing their own knowledge and using their traditional knowledge coming from generation after generations, and they know how to adapt with this climate extremes. Now, particularly in coastal areas, um, in this area particularly, there are so many compound events, meaning that water is coming from the inland through river networks, and also coming from the coastal flooding from the sea. So both this happening together, and we call this compound events, and it intensify the magnitude of the impacts of climate extreme. Therefore, people who are vulnerable under these areas, they are trying to develop new innovative adaptation practices, and they show a big success in this adaptation innovation. And we have um, National Adaptation Action Plan, which is prepared in 2005, and one of the first country in the world. And also in 2009, we have developed a National Climate Change Strategy and Action Plan. In this document, and intensive and more comprehensive climate change strategies and action plans are designed, considering considering the historical records of extreme weather and climatic events, and also on the basis of predictions from our meteorological department called Bangladesh Meteorological Department and Water Development Board, and other academia and also experts in the relevant field. And recently, um, Bangladesh has taken different activities. For example, 8th 5-year plan, which actually focus on the proper climate strategy and prioritizing climate change adaptation and disaster risk reduction. And it promotes the institutional capacity building for addressing climate and weather extremes. As you know that in SDG 13 is one target is to enhance the capacity and resilience towards climate change impacts. So to mainstreaming this target into our national policies, we have also Vision 2041, and 2041 also promotes the climate-friendly, sustainable infrastructure and innovation. And also recently we developed Delta Plan 2100. So it's a 100-year plan, and it covers all the aspects of weather and climate extreme to achieve safe, climate resilient, and prosperous delta. And in that case, also a group of scientists, including me, also working and collaborating with different peoples, how we can make our delta more climate resilience, and how the numeric weather prediction can help to take more climate action. And also for SDG 13, we are committed to achieving SDG goals, and we are also working closely with different partners, including public and private, all the sectors. So in this figure, actually, you have seen the chronology or historical development of climate action in Bangladesh, starting from 2005 to more recent 2020. So not only in Bangladesh, but also in other countries of the world, particularly more climate resilient or climate vulnerable countries, they are focusing on more adaptation. As we know that we have two solutions: one is mitigation and another one is adaptation to weather and climate extreme. So for developing countries, it's actually more realistic to go for climate change adaptation rather than climate change mitigation. So that's all from my side, and I hope you you can now understand the extreme events and how actually it affects the all dimensions of our society, and how a more accurate prediction using the more state of art like machine learning or artificial intelligence help to predict this weather and extreme events more accurately. Although it's not a easy task, is quite challenging. For example, for heat waves and temperature or droughts, it's a bit possible to do this more accurately, but for extreme precipitation and other climatic hazards which occurring in very short time, it's actually really challenge for the way scientists. But hope is there. We are working together. We are exchanging our knowledge with different parts of the world, and we are working collaboratively in joint project. We are learning from each other, from different actors, practitioners, experts, and also youth. And I hope these activities also help to transfer knowledge, to take more actions, and also more innovative climate change adaptation practices around the world. So thank you again. Thanks inviting me, and I wish Climate Social Forum a grand success. And thanks again for inviting me. And at last but not least, Merry Christmas and a very Happy New Year to all from my center, Wegener Center for Climate and Global Change. Thank you very much.